So our next speaker is from Asimovo, Christine Fraser. Please welcome.
Hi, everyone. And thank you, Wesley. Thank you, Francesco. And where we go from kind of one extreme of Francesco, 20 years in robotics, we are Asimovo. We're a startup actually based out of here in Rotterdam. So we're on home territory today. So it's nice to speak to you all. Okay, so most of you won't have heard of Asimovo. So we're about 1.5 years old, and we're a Robo DevOps platform. And today I want to speak to you about what we're doing to help you publish your research or teach robotics in a new way. So we also, the idea came from European funded projects where we had lots of different partners all working together who, 5 research institutions, 5 commercial institutions, all working on a big R&D project. But after you'd go away and come back 2 months later, none of your work was compatible, or the parts didn't fit together, and people forgot to tell you that they changed something in the hardware and that the software doesn't work anymore. So we said, hey, there must be a better way. But is this problem only what we're suffering from, or are other people suffering from it? And the more people we speak to, the more we find out that actually robotics is so fun, it's great, but it's still very siloed. People are still working very much on their own little worlds, and not enough as an industry to collaborate, not enough about standardization, not enough professional tools for the industry. So we said, let's see if we can do something about that. So we believe that we should be smarter in the way that we build smarter robots, that actually our vision of the future is that robots work with us, that we work in high-performance teams together, making decisions together, helping each other. And in order to do that, then you need to have ways that humans can interact with robots that are more standard, or robot-to-robot interaction. So for example, we work here with the big hospital in Rotterdam about the hospital of the future. And they don't say we want robots in their hospital. They're looking for different ways to automate their tasks and make them more efficient. So that's really what we're all about. So what we've done is we've embraced the power of the cloud around collaboration and being able to connect to the right processing power. So you should be able to process on the robot till it becomes too much, process on your laptop till it becomes too much, move to the cloud, move to supercomputer. But some of the development tools, especially the RAWs or open source collaborative ones, don't work very well in the cloud. So everyone still wants to work locally. So how can we do this and work both ways? So we talk about a software-first approach to robotics, a very iterative test, try, retry, learn loop. But you also want to be bringing hardware into the loop as part of that process. But rather than everyone having to be in the same room as the hardware, you can now connect to that remotely. So what we've got is we've said, what is it that we must have in order to be able to do robotics development? You have to be able to work both in the cloud, but also locally. Your team and your robots can be located anywhere. We bring them together, that everyone can work off the same tools, the same versions, the same. And this works whether you're working on a course and to teach robotics, or whether you're all developing around one big research project. That you break up that work into more modules, so that those modules can be used by others or used in different ways, and connect all of that with your integrated development environments that are either on your local machine or in the cloud. So if you're teaching robotics, or you've got a large research project, you can set up a repository in the cloud. You can all work off the same versions, the same gazebo tools, or the same ROS operating system versions. You can then populate that with the work that everyone's doing in the cloud. But then everyone can branch off and work locally, but you collaborate on much more than just code. You're collaborating in your test environment, you're collaborating in your behaviors, and you can set that up as a course, and you could have 100 students all working off that digital version, but then collaborating and working off and accessing the physical robot when needed. So this combination allows people to accelerate in how both they're teaching, and what we find is that this is also a great way to publish your research also. So what we have here, and in one of the demos upstairs, you have a research project that was done in a much more modular way, that's actually able to be, anyone can just access, go in and demo it, go through the documentation and run the commands themselves. And what we find is that that test environment is now able to be taken and is now being used by 2 other research projects because it was done in a modular and more collaborative way. We work with people who've got physical robots who want to have digital twins that people can access and work on. And for example, here in the Netherlands, we've integrated with the cloud provider Surf so that all the Dutch universities can access the platform via their normal cloud compute processes, so that those students can work off their local machines, on-prem compute, or move to the cloud or supercompute whenever they're ready. So you probably won't have heard of us, but please come past our booth. We have a booth upstairs. As I said, one of our partners, Saxion University, has also got a demo of some of the research that we've done together. We've got a number of open projects here in the Netherlands around self-driving cars that are done at national scale that the platform is being used in. And of course, you can just go to our website, sign up for free, and access any of these research projects, download them, check them out, demo them, run them for yourself. Please come and talk to me afterwards. We're here all week, and I'm also part of a debate on Thursday. Thank you, everyone.
Thank you very much, Christine.